Here we set out to prove that the derivative of sine x is indeed cos x, and we can do that with a little help from a few facts that we've already established. Okay, so first off, we have an identity from somewhere back in trigonometry for the sum of two angles. So sine of a plus b is sine a cos b plus cos a sine b. So we won't go back and prove that. We'll accept that as fact, and then we have two other facts that we'll accept for this proof. And these are the trigonometric limits. So we have the limit as x goes to 0 of sine x over x equals 1. That we will show later once we have L'Hopital's rule. And then the other fact follows from that limit with sine x over x. The other one is limit as x goes to 0 of cos x minus 1 all over x equals 0. Okay, so we'll use these three facts to do this proof. Let's do it using the limit definition of the derivative. Okay, so we're just looking at the derivative of sine x. So recall the limit definition of the derivative is the limit as h goes to 0. So limit as h goes to 0 of f of x plus h, so that's sine x plus h, minus f of x, so that's sine x all over h. Okay, so now we'll hit this first expression, sine of x plus h, with the trig identity here. Expand that out. So this gives us the limit as h goes to 0. Expanding that out gives sine x cos h plus cos x sine h. And then we still have a minus sine x kind of hanging on over here to the right, all over h. And now we're going to rearrange this a little bit. So I'm going to take this sine x cos h minus sine x and combine those together. And then I'm going to take cos x sine h and bring that out into a different limit. Okay, so this gives us the limit as h goes to 0. When we combine these two red ones, I'm going to go ahead and factor a sine x, since both those terms have sine x in them. So sine x comes out. That leaves us with cos h minus 1 in these terms here, all over h. Okay, and then plus, and I'm bringing this blue term out to a whole nother limit here. So plus the limit as h goes to 0, of, what do we have there? Cos x times sine h all over h. Well, now let's use our facts, our trig limit facts, right? In the first one here, we have cos h minus 1 all over h. But this fact tells us that that is 0, right? It says cos x, but we're just replacing x with h in our case. So this whole term goes to 0. Over here on the right, on the second limit, we have sine h over h, and this limit as h goes to 0. Well, this fact tells us that that equals 1. So this whole thing goes to 1, and then we have this cos x that's just along for the ride. So when all is said and done, we have 0 plus cos x times 1, leaving us with simply cos x, which completes the proof. So we did a visual proof before using the graphs of sine x and cos x, and now here's a rigorous proof using a little more analytical approach.